Hi guys, today's problem is about finding a well-known infinite sum or series. Note that in the series S, the denominator terms are the products of two consecutive integers like n and n plus 1. So our problem is to find S equals sum over 1 to infinity of 1 divided by n times n plus 1. First, I claim that the sum S is convergent. So claim S is convergent. For any n, I have 1 over n times n plus 1 is smaller than 1 over n squared, because the denominator here is larger than here. Now if I take sum over 1 to infinity of both terms, I get sum over 1 divided by n times n plus 1 is less than sum over n equals 1 to infinity of 1 divided by n squared. The left-hand side here is nothing but S. So I have S less than sum over 1 to infinity of 1 divided by n squared. Now I need to give a short recap at this point. The infinite sum zeta of S defined by sum over 1 to infinity of 1 divided by n to S is known as Riemann zeta function. Zeta function is convergent for any real numbers greater than 1, which means that it has a positive numerical value. So the right-hand side here is nothing but zeta of 2. We conclude that S is bounded from above by a positive real number and therefore S is convergent. Now it's time to find the value of S. Let's suppose that the terms 1 over n times n plus 1 can be written as the sum of two fractions, like a divided by b plus c divided by d, which is just ad plus bc over bd. By comparing these two fractions here and here, the most straightforward choice is whenever bd equals n times n plus 1 and ad plus bc equals 1. And from the first relation, we can let b equals n and d equals n plus 1. Now, if I plug them into the second equation, I get a times n plus 1 plus c times n equals 1, which is a plus c in parentheses times n plus a equals 1. If the factor a plus c is non-zero, the left-hand side can grow infinitely large with n, which is impossible because the right-hand side is a finite number. So the only possible choice is whenever a plus c equals 0, and from here c equals minus a. But if this term vanishes, I have a equals 1, and from here I get c equals minus 1. Now I plug them into here and I get 1 over n times n plus 1 equals 1 over n minus 1 over n plus 1. So I have s equals sum over 1 to infinity of 1 divided by n minus 1 divided by n plus 1. And this is nothing but a telescoping series. Let's write a few terms to see the pattern. S equals 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 plus so on, which can be rearranged as 1 minus parentheses 1 half minus 1 half minus 1/3 minus 1/3 minus 1/4 minus 1/4 minus so on. And all terms in the parentheses cancel out, and it remains us with 1.